welcome to attending this Actran Acoustic webinar. So today's webinar is the sixth one of the 2014 Acoustic webinar series. And in the previous Acoustic webinars this year, we had a major focus on applications that can be handled by Actran on the modeling of physics, such as acoustic radiation, acoustic transmission, or acoustic treatment, etc. And today we will focus on another topic, which is the automation of Actran computations through the usage of Application Programming Interface, or API for short, and see how the API can help to increase our productivity while doing acoustic analysis in Actran. So today's agenda goes like this. First, I will introduce to you the concept of Application Programming Interface, or API, and then we will take a look at the content of the API within our Graphical User Interface, and this includes the types of functions and objects that are accessible, and on how to retrieve session files within this graphical interface. Then we will review the use of this API through scripting and sessions for different purposes, such as saving an actual state of the graphical user interface, or relaunching a part of a post-processing step, or automating the Actran simulation, or even performing the parametric studies. And there will be some live demos while I do this presentation, and our webinar will finish with a Q&A session. So first, as introduced several times in previous webinar sessions, we know that Actran software is divided into different modules for solving basic acoustic problems or more advanced and complex vibro-acoustics or aero-acoustic problems. So all these Actran modules are accessible in the Actran VI, or the Actran Graphical User Interface, and it is essentially in Actran VI that the Application Programming Interface is accessible. So some words on Actran VI before starting the review of the API. So I will first briefly introduce you the Actran VI and this some accessory utilities. So Actran VI is the dedicated pre- and post-processing tool for acoustic modeling in Actran. And it allows us to perform various types of actions from the import or export of Actran analysis or meshes to the creation and edition of Actran analysis. It also contains more and more meshing capabilities today as we release year by year new Actran releases. And Actran VI is also used for visualizing results calculated by Actran or results by other CAE tools like Structure FEA or CFD programs. And it supports several types of result visualization, as we can see on this page below here. And inside Actran VI, we have two utilities for the post-processing of Actran results in terms of frequency response functions. And these two utilities are called the PLTViewer and the Waterfall Viewer. So both PLTViewer and Waterfall Viewer can import different result formats, including external data provided by other tools such as MATLAB or Excel, Sheet, or other types of results. And they can combine different results into a common visualization. And these two tools also contain several types of operators or functions specific to acoustic analysis, and allow user to create its own set of functions. So the data can either be visualized in PLTViewer, which allows a 2D plot curves, or in waterfall viewer for visualizing waterfall diagrams when an output varies as a function of two parameters, for example. So here is an example of the sound pressure level radiated by an engine according to frequency at the horizontal axis and as a function of round per minute of that engine's working condition in the vertical axis. So being familiar with the graphical interface now, let's look exactly what the Actran API is. So the Actran API is an interface, or in another word, a language that allows communication of Actran with its users or with other software. And it includes the specification of different actions that can be taken by the user, the structure of the data that can be accessed to. So the entire API structure, it actually defines in total what can be done and what can be requested within the Actran environment. So the main benefit of an API is the fact that every user can access it and create applications based on it without having to rewrite some built-in functions in the software. Now, in practice, for Actran users, the usage of an API could allow them to control and operate different actions that they could otherwise perform manually within the Actran VI or PLTViewer or waterfall viewer. And the API could also allow the users to access internal data structure easily, which is a advanced, let's say, advanced usage. And this usage is mainly to facilitate the automation of post-processing steps. So as I mentioned previously, Actran VI and its utilities, PLTViewer and waterfall viewer, all have their own API. So for you to know more, Actran API is based on the Python language. Although I would like to point out that a user does not need to master the Python language in order to use the Actran API, and this point can be illustrated by examples later that you will see through this webinar. So, and now being familiar with API, now we reach the concept of a session. An Actran session is a collection of multiple API command lines. Since all performed actions in the graphical user interface can be translated into a particular API command. So all these operations are therefore recorded in a session file within the GUI, as we can see here on this page. So as we can see that although it is based on the Python language, but the syntax and usage is rather explicit and easy to understand with quite a straightforward nomination. So what are the sessions recorded? Actran VI contains an interactive console which records the different performed operations. And this console can be used to perform operations interactively to retrieve help on the API. Also, all the operations are also automatically output into a session file. Well, it can be output either automatically or manually. So now I will just give you a very short first insight of the Actran API or command. Now, in the Actran VI interface, I just loaded a finite element mesh containing a acoustic cavity inside a ski cabin, and we have some volumes. I have this main volume and three small volumes on which we will define acoustic treatment material by porous material. Now we can see on the bottom left we have this console, and whenever I execute a action, for example, in Actran VI, create a direct frequency response analysis, we have this this window popped up, but also a line that is written here on this console. And now if I add a frequency range to be studied, for example, from 10 Hz with a step of 10 Hz, let's say, to 200 Hz. And now when I validate, we have this new line. Now if I change this value range, then the new line is dumped. Also, when we create a material, for example, a fluid material, we have this line added here, and in this fluid, which is air, if I define the speed of sound to be 340 meters per second, we have another line dumped here. So this is the API comment together making up a session. Now I'm coming back to the presentation. Now let's go a little further in the principle of the API. The Actran API, it provides a full set of functions and object types that can be used. So the complete list of functions and object types are obviously documented within our user's manual, but here we will review just a few of them just to explain the principle of the API content. So the API can access all types of objects, like as we have seen, the object can be a material, a mesh, a domain, a component, which are Actran specific terms, boundary conditions, analysis, tables, and visualization containers for the post-processing. So these are quite Actran specific terms here. So for example, this command, this one as we see here, it creates an object called Acoustic1, which is a finite element component defining an acoustic cavity, like this inner cavity that we have seen in that ski cabin. So this command is associated with this user graphical user interface action. And after the concept of object, we have the concept of functions types in Actran VI. The whole types of functions can be divided into 5 main categories. First one, creating an object. For example, creating a material or creating a boundary condition. And then retrieving an object or finding a object. For example, retrieving the material, its ID number, etc. And then modifying an object. For example, changing the speed of sound in a fluid material. And then another utility is to add an object underneath another object, or in other words, associate two objects. So typically, to associate a physical domain to a boundary condition or to a loading condition. For example, if we want to apply a acoustic diffuse sound field excitation on a given structure surface, then we will need this association function. And of course, any object can be removed through this remove function. So besides these basic functions, many other functions are also available. For example, import or export Actran input files, or import meshes, and perform some meshing operations, as these operations are more and more these types of meshing operations are available in our new release. Modify the interpolation order of a mesh, or create local microphones, field points, exporting an image or an animation to a file. We can all achieved by these functions. Now, function types in PLTViewer. So for post-processing the frequency response functions within the PLTViewer, there are also a number of API comments that I will go through rather quickly. So when importing an Actran result file, the selected results are imported and become an object which can be referenced. And three main operation types can be performed in that PLTViewer. They are the creation, addition, and removal of the different objects. And of course, many additional functions available, such as the import of a result file, the export of a 2D curve into text file, or into an image file, etc. Now we have seen a introduction, let's say, on the API session. So now this page shows where we can get help if we are Actran user and we want to use this API and session functions. So due to the extensive amount of functions, object types, and properties, it is important to get access to a complete help. And as I said previously, the complete list of functions, including their arguments and their syntax, is provided in the Actran manual. And also, for advanced users, an interactive help is also provided within the console of the Actran VI. And for example, the help comment provides the help for required functions. So now let's come to more application-oriented part of this webinar. Let's now review what exactly can be done with these available APIs. They can be useful for several purposes. First, the most basic application of the API is to save and to load the current state of an Actran project in Actran VI. And then template for a typical analysis using the same type of component, same type of boundary conditions, or same type of materials can be saved for further usage. And then third, pre-processing and post-processing steps can be edited to avoid repeating manual operations. And then when pre- and post-processing steps are already automated, and then we can add the computational step, meaning the running of the Actran model into this automated chain. Finally, parametric studies are also a typical example of API usage. So first usage is quite straightforward, saving and loading Actran projects. So through a example, I will quickly show you loading of a Actran project through session. I will first clean what we have here. And as we can see, In this folder, we have on the right side of my screen, I have this a mesh file, which is the ski cabin, but it includes only the mesh, and has a session file that has been previously dumped by Actran VI, and as you can see, it contains several lines of API. Now, in Actran VI, if I click on Load Session and Automatic port file, I will be able to now load this session. And as you can see, it will execute all these lines in the session, and by this, it builds this analysis automatically. We have these materials created, analysis created, and different parts. For example, this cavity having this air material in it, and these three patches, one floor and two seats that are made of porous material for the acoustic treatment. And we have these properties of porous material defined here. And all these are made available due to this session file here. Okay, so that was the basic importing or loading a session. And then session and scripting as pre and post processing tools. So the usages of sessions and scriptings can ease many different pre and post processing operations. Again, by reducing the number of manual operations. A typical example here is to modify the parameter in an existing session file to reproduce a different, to reproduce the process, but with a slightly different, let's say, input file here. And this without having to perform all other operations. So on this example, the mesh file supporting a computation can be modified just by changing the file name, the mesh file name within this session. Also, during post-processing, sometimes we need to perform many times identical operations, and they are needed to perform when comparing different results, but with similar types. So by copying a typical section in the post-processing operations session, we can then easily produce all these different results in one or in multiple figures without having to perform the manual operations. And then next usage is automating a complete Actran simulation. So if the pre and post processing steps of a typical analysis are already automated, then we can simply add the running of the model into that chain. So the running of the model is in the middle of this session file here. And we see that three different steps can be merged into a single session file by using the run function to directly obtain this solution. So I will again quickly give you this demo. This automation. Okay. In this session file, it includes the pre-processing, the running of the model, and the post-processing. As we can see, at the end of the post-processing, we will export an image, while the PLTViewer will quit itself automatically. Now, to perform the session, just type Actran VI -X for executing the session, and the name of the session file. So it opens Actran VI. as this section indicates, and then we can see in that folder. Now it is building this model, and then it will compute it, and we see that the PLT file is calculated. And then, while during a very short time, it opened the PLTViewer and followed these instructions for the post-processing and output this snapshot of that sound pressure level in that on the microphone position in the ski cabin. So now we see that the final result being requested output. And this is convenient if we want to automate this process even in non-graphical mode. We can even launch this on a, let's say, on a Linux cluster just by adding this dash n at the end. Then we don't need any graphical support to create that image by Actran. Okay, so now we come to at the last topic of today's webinar, which is parametric studies. And this is another typical usage of API here. The purpose of parametric studies is to, in general, to assess the impact of certain parameters on the design. It consists in choosing the parameters of interest first, and then defining the parameter range and values, and then finally analyzing the result of each parameter variation. This could include the sensitivity of the result on change of a certain parameter. In practice, a parametric study, it requires launching several Actran computations for which the parameters has to be modified. And the usage of API is a key feature for automating the calculation and post-processing. Usually, but not exclusively, there are two types of parameters that are considered in a parametric study. The first type is the parameters. It's a change of parameters from external input. Now, this is only just an example on a change of mesh, but we can imagine that there may be changes of dimension of the problem specified in the mesh file, change of the structure vibration result for a subsequent acoustic radiation, or change of a CFD data containing flow result for a subsequent aero-acoustics analysis in Actran. And in many cases, only a few amounts or even no changes need to be applied on the Actran input model file itself for producing all these results. And then a second type of parametric change is the parameters within the Actran model, such as the component or material properties, boundary conditions, for example, the level of forces added or the distribution of forces added on the surface. So in that case, most of the time, scripting will be required for this type of parameter studies. When I say scripting, is to combine the API sessions with some basic scripting skills in Python. Okay, so let's look at this last case study. It is a parametric study of the acoustically treated ski cabin that we have seen previously. Here, the parameters of interest are the two properties of the porous material on the seat and the carpet and the floor at the acoustic treatment. And the two parameters we wish to modify here is the porosity and the flow resistivity, although we can include more parameters to be studied in this example, but here we are looking at two of them for the moment. And the aim is to assess their influence on the acoustic results on the microphone inside this cabin. So for that purpose, we will need several files to be prepared in order to automate the model creation, the computation, and the post-processing of the result. And so there's a master script that will drive the whole process. And this master script will read several other times, including the template file, which are already initially dumped Actran VI sessions, but also the waterfall viewer sessions. And the master file will also read that the parameter file, which defines the parameter values to be studied. And then, of course, we will need a mesh file that supports the physical domain. So now let's come back to over here. You can see here. So this mesh file is the ski cabin as we have seen, with this cavity and these three patches on the seat and on the floor. And this master file has been programmed using some basic Python programming, which is actually quite easy to learn, because the Python language is actually quite a simple language for starters to learn. And you can see here, those are some declarations of import functions, which are just standard. And the main action is here. We have two loops. So for in is one loop on the first parameter, and then the second loop within the first loop is the iteration on the second parameter. And these parameters being, so here in another file, which is quite simple, they are the variable 1 being the flow resistivity. Now we are having two values, but we could have many of them. And the variable 2, which is the porosity. Okay. And a template file is also required. As I said, this is the file session dumped by the Actran VI. Now, so I will first launch it because it will take a few 2 or 3 minutes. To launch it, I type Python and master file. Now, so coming back, by the way, we are launching this the whole process in a non-graphical mode, as we can see here. When we run Actran, we are using this -n argument for non-graphical mode. So now come back to the template file. As you can see, it's the standard session, but here on this line, we are replacing the porosity by this this symbol %s, and flow resistivity by another symbol. And then in the output result file, we are also replacing the output file name by two. Oops, oh, it's already finishes. But I'll just come back to a little more. So we're replacing these two factors in the output PLT file by this %s, and in this master file, it will take the parameters defined by ourselves to replace these four locations in the template in order to make the Actran model as what had just happened and launch them and get the PLT files. You can see one PLT file is a combination of the the flow resistivity of the porous material and the porosity of it. And finally, we have this waterfall script containing about 10 or 20 lines that we have seen just now. Right. To read all these PLT files and arrange them in a certain manner in order to visualize this waterfall graph. So the color indicates the sound pressure level at that point in the microphone location at a certain frequency, and we can see that here we have only a 2x2 matrix. So we have on the left add a sample or vertical cut. So on with the low resistivity of 80,000, I have two values varying depending on the porosity, and on the, for example, on the porosity of 0.85, I have two variation on two flow resistivities. Now, if we had more time, we could launch, example here, a variable strings containing more parameters, more variations, and to obtain a more refined result. And we can see that now, if blue color indicates a quieter location, we see that the optimum direction in terms of optimization of the result will tend to move to this position, which is a certain combination of the foam porosity and the flow resistivity. So, that will end my demonstration and presentation. So as a conclusion, we see that during this webinar, the concept of the API and this particular language has been introduced to you. As we have seen, the API can be used for several purposes, from the basic to the advanced, including saving and loading Actran projects, creating templates, using the session for editing the pre-processing session or the post-processing session, automating a complete Actran simulation, including the running of the model itself, and finally, performing parametric studies. So as such, it enables the integration of Actran acoustic simulation within the design cycle of engineering products. Okay, so that was my presentation. With that, thank you for attending this webinar. And let's go to the Q&A session, please.